you. Be well. So we move on to Suzanne Lee, who I see is online with us. Suzanne is the founder of the Biofabricate Summit, and that effectively nurtures a community of biomaterial innovators. So we're quickly and swiftly changing the focus of our presentations, but absolutely still design with meaning. So Suzanne, are you there and you can share your screen?
Hi, Saz, can you see me?
Yes, we can. Welcome. I know Suzanne's in the US, so it's an entirely different time of day. She is English, but based there now. So it's early morning. So I appreciate it, you taking the time. Thank you.
Oh, no, thank you so much for the invitation to join you, Saz. It's an amazing lineup of people that you brought today. Incredibly inspiring stories. Well, I just wanted to sort of start by giving a little bit of background because my journey has been pretty long at this point. So I started life as a fashion textile designer in London, but always very much a sort of science fiction fan. So I've been future obsessed for a very long time. And in the beginning, I suppose if I go back 20 years, I was invited to write a book about the future of fashion. And I didn't really want to focus on next season or the one after. I was really inspired to think really far out and say, what might fashion look like in 50 years' time? And for me, just chatting to my fashion friends, they couldn't see that far out, or it became very kind of untethered to reality. And so then I started speaking to scientists and engineers and the people who were working in laboratories at that time, developing new materials or new processes that could enable us to make things in new ways. And so that became super interesting to me as a creative. And I was like, actually, we can start to feel out what this future might be like by spending more time with these people. So that was really kind of what changed my life, was talking to lots of scientists, and in particular a biologist who, when I said, how else, I'm interested in what fashion's going to look like in 50 years, how else could we make things and what else could things be made from? This is the vision that was presented to me. Forget about petrochemicals. Forget about growing crops in a field, and forget about animals as the source of fibers and fabrics. We could actually make materials using life itself in the form of microbes, bacteria, yeast, fungi, algae. And this was just such a sort of bizarre vision to me at that time, this notion that there is a form of cellular production for fibers that could reimagine how we manufacture and create things. So this was kind of a light bulb moment to me, because what it painted was a vision of growing fashion literally in a vat of liquid from a cell. So completely different. And this idea that you could potentially grow a fiber into a fabric, into a finished three-dimensional form. So I had this vision of sort of being able to magic dresses from vats of liquid. And so that for me became an obsession. And I coined this term Biocouture, the coming together of biology with couture as a maker. So this was the kind of vision. And then this is really where it all started. So this is a time lapse of bacterial cellulose fermenting. And what's happening here is the kind of invisible microbes were feeding on a nutrient source, in this instance, sugar, and spinning fibers, and then literally forming those fibers into a non-woven sheet of material. So I ended up in London 20 years ago with a fabric farm. These vats of fermenting liquid were producing sheets of material. And that material, this is what that looked like. These were bathtubs filled with a sugary green tea solution and a live culture of, in this instance, like a kombucha culture, a mix of yeast and bacteria that feed on the nutrients in that bathtub and produce a thick skin on the surface. The skin could be harvested, dried very naturally in the sun, and then turned into all kinds of materials or garments. And along the way, we did lots of kind of experimentation. We discovered that the cellulose would stain very well with things like food waste, fruit waste. It really took color exceptionally well. So what you're looking at here are just fruits that have been put onto the wet material that then take on that color when they're dried. So we tried many different processes, and this is, I want to emphasize, this is 20 years ago. Okay. So at the time, we weren't thinking about sustainability in fashion so much. I would say that the majority of the industry was not focused on discovering new fibers or really questioning processes. But what I learned doing this process was actually a lot of things that questioned how we currently produce things. How do we obtain raw materials? How do we dye them? How do we construct them? So through this process of working with this particular biomaterial, it called into question all of those methods of production for me and their impact. So from these fruit experiments, this was one of the first garments was a jacket that was an engineered print where the color was coming just from the fruit and vegetable stains on the cellulose. And then there was another discovery, which was this one, which was as I was drying down the materials on a wooden sheet, there happened to be some metal, some iron on the sheet that turned the material black. So there was a discovery there around, actually, we don't even need to add pigment or dye. We can use a process, a natural process like oxidation, where just the pH of the material will actually change the effect of color like this. So that again became exploited as a new opportunity for adding color without dye or printing. So this bomber jacket, biker jacket, was the result of that. And this was playing with the idea of an animal leather, which would typically be a black leather jacket, which might have metal studs on it. And this whole idea was flipped. So the metal studs went onto the wooden sheet. The wet material was dried down onto it. The pH of the material meant that there was a color change. So where you would normally add metal into the jacket, we used the metal to create the black. So the whole thing kind of became a negative. And it was just a really interesting process to sort of explore, what does the material tell us or enable us to do when you take away your kind of pre-existing notions of what something should look like. So I was very keen to make garments with this really unusual material that was still familiar to people, that didn't feel too abstract, that was still rooted very much in the kind of clothing that people would typically wear. And so that also led to this one. This is like a really classic denim jacket. Obviously, denim jacket's made from cotton that grows in a field. And this material is essentially the same. It's cellulose. It's 100% cellulose. So this garment, you can see on the left, it was all hand stitched, and then it was dip dyed in indigo. And that was an astonishing process to watch, because it's so absorbent, the bacterial cellulose, that it takes up the color very quickly. And you needed much less indigo and much less water to actually bring this jacket to fruition. So this was the final garment And ordinarily, to achieve a color this dark, you might need up to sort of 18 dips in an indigo vat, whereas this one took just one and really took that color in about 30 seconds. Really astonishing uptake. So, that already started to bring into question for me, why are we not leveraging these kinds of materials in fashion? If a traditional garment that is grown of cotton and indigo dyed could be, say, 10,000 liters of water, what I'm producing here is maybe only using 30, and that's without me even trying to optimize it. So I'm able to grow the fiber and color it in a very small, with a very minimal amount of resources. So all of that to me was very exciting. Everyone I spoke to in fashion thought I was a crazy person. Imagine, right, talking about fashion, bacteria. The future of this is this. At that time, this just wasn't an idea that anyone could even understand. Why would you want to do this? Because we weren't thinking about a shortage of resources or the outsized impact that fashion has on the planet. So for about 10 years, I spoke to investors and brands about, actually, let's totally radically rethink where materials come from and how we can produce fashion. And it just fell on deaf ears. And after 10 years, I pretty much gave up. But in that time, I really had discovered this whole new world of biology as a creative. And it made me think about what we do in general. And it's not just one process. So biology and thinking about fermentation of a fabric means that we can potentially use less land, less water, less energy, less toxic chemicals, and no animals. Is that not a compelling vision for where we need to take our industry? I was still convinced that biology is going to be the answer to a lot of our issues in our industry. And even if we look at issues like CO2 emissions, there are now companies who are able to take that as an input for biology and transform it into materials for the fashion industry. So in this 20-year period, I've sort of seen this field develop from one of, like, not just skepticism, but complete comedy, where people just thought that I was messing around, and it was all just entertainment and not real and had no potential future application. And we've gone from that 20 years ago to companies today who are able to take carbon emissions, feed them to a bacteria, and make a dress like this. So this is actually a Zara dress, which is made with a yarn that comes, the precursor comes from CO2, but the transforming nature of it is done with biology. So for me, seeing that journey where biology can now do this, transform CO2 into a chemical that can make a yarn, is the beginning of a new kind of vision for how we manufacture fashion.
What if there's more than one way to think about carbon emissions? What if they're actually part of the solution? What if, instead of waste, they're a resource? What if we could find ways to turn them into things we see and wear every day? What if someone just needed to take the first step? Clean cloud, made from carbon emissions.
So that's actually, that's a teaser for a shoe that On Running are doing with that same fiber. And we're going to see more and more of these yarns coming into production using that same source. So actually turning carbon emissions through biology into new yarns and products for not just fashion, but everywhere, really. So I feel really strongly that this idea has come of age. And like I said, it's not just one organism. So I started off working with bacteria, but people are also using yeast and algal cells. They're using fungi or mycelium that you see growing here, which is the root system of fungi. And the idea has not only taken hold in the industry, but we're starting to see major investment from household names, but also very prestigious brands in the world. So, for example, the coat that you see here from Balenciaga that was launched last year may look like black animal leather, but it is in fact a fungal material. So this is from an Italian company called Skim, and the material is called Effea. And this was grown on agricultural waste and is a mycelium alternative to animal leather. Just in the last week, we saw this garment on Stella McCartney's catwalk show in Paris, which is a algae yarn from a company in the US called Keel Labs. So this material is, is seaweed derived. And in the past, we've seen seaweed fibers, but they've always been a very small percentage. But the percentage of the actual seaweed in this yarn is way higher, between 50 and 80%. So these are no longer prototype materials in labs. They are actually reaching the market. This is another one. This is a Japanese company called Spiber, who are, you can see in the background there, that's their biotech facility, and they're fermenting proteins, completely novel proteins that you can turn into yarn. And so these jackets are being made in collaboration with the Japanese arm of the North Face called Goldwyn. Again, real garments for sale today, and fibers that come not from animals, not from petrochemicals, and from a fermented protein, bacteria, or a yeast cell. And so this is also just a t-shirt from them, but I wanted to highlight, they have, instead of a garment label, they're calling it a nutrition label, and it calls out the content of the garment. So you can see here, it talks about, this is protein. Silk is a protein yarn, but this is a protein yarn that is microbe derived. And they're actually, trying to educate their customers about this new origin for materials. And I also just wanted to say, this isn't just a fashion opportunity. So this is obviously the interior of a Mercedes car. It's one of their latest electric vehicles. And there are multiple materials in the interior of this car that are certainly not animal derived or petrochemical, but come from plants or microbes. So as we think about a material revolution, it's not just going to impact fashion, it will impact all of the places where we derive these materials. So 20 years later, that same material that I was growing, that everyone in fashion told me no one would be interested in and there was no market for, in the last week, we've seen launches from Ganni with a company in London called Modern Synthesis, who have a very unique process for growing bacterial cellulose. And that's what the handbag is here. And then on the right-hand side, you can see this amazing jacket made by Ganni from a company in Mexico called Polybion. And again, it is a fermented fabric from bacterial cellulose, very similar to the process that I was doing 20 years ago. But now it's the right time. People understand that we need to think about our resources in a much more radical way. So these materials are made with minimal water, minimal impact on land. Their factories can be using renewable energy. So the carbon footprint of these garments is way lower. And in the instance of both of these, potentially they could be compostable. So what we do now, I've moved, my journey as a designer has been, very varied over time. So I went from the fashion industry, got involved in biology and synthetic biology, ended up joining a biotech company, Modern Meadow here in New York, but founded Biofabricate because we can have impact as an individual designer. And I think probably what I did back then was start a whole movement of people, designer makers, thinking about growing their own materials. But actually to have real impact in the world, we need to support innovators with funding. So they need a platform to really share their innovations. And then we need to bring really important brands to the table to get them to partner with these innovators so that we can scale these materials and have the planetary impact that I think we're all seeking. So today, I do not grow materials. I haven't done that myself for at least a decade. What I do is I work with others. I work advising startups, working with global brands, and convening a global community who are all exploring the many different ways that we can use biology. So we do things like Sas mentioned, we have an annual summit where we bring all of these biomaterial innovators together and connect them with investors and brands. We do a lot of educational work. So if you look online, we have a biomaterials platform. Sas, I can share that with you, actually. That's this one that is a real kind of educational platform for answering that question, what are biomaterials? Many people are still just discovering these for themselves. And we also have done things like work with Fashion for Good to produce this very lengthy report that dives very deeply into many of the questions people have about these very different technologies. So these are both free resources that are available. You can find them on our website. And I just wanted to end, I think, with a video from Pangaea, which I also think is really inspiring, because we aren't crazy no more. And there are many, many people now who are embracing this vision of the future of fashion is about biology. So if you'll permit me, I'll play that. And I just wanted to leave you with this statistic. What we have done so far today with biology and materials is with just scratching the surface of what is possible. And this is the reality. We have only discovered 0.001% of all species. So we do not have to go into the natural world and exploit it. We can now study the genetic code of these living organisms and find a way to synthesize them so that we don't need to grow a plant or raise an animal or use petrochemicals. For the origin of material, we can do it with biology. And this is what gives me the hope for the future.
Thank you, Suzanne. I think you are a true visionary in this space, and I really thank you for sharing your work. And I know we have the link to Biofabricate on your bio on the website, so anybody interested in more information can follow you there or attend your summit. Where is it this year?
The summit actually is, the next one is in January in Paris.
Fantastic. All right. I know you have a full day, and I believe it's your birthday, so
Thank you. Good luck. And I look forward to watching all the other talks back.
Thank you. All right, be well. Take care.
Congratulations.
Guys.
It was amazing.
Bye-bye.
What a cadeau. You give a cadeau to us. So much.
Okay, so.